Hello, my name is Paige Gott, and I'm a Senior Ruminant Technical Manager for dsm-firmenich North America. In this video, I'm going to provide a brief overview of the results of our 2024 U.S. corn mycotoxin survey. This survey represents samples submitted from throughout the U.S., which were screened for a panel of 18 mycotoxins, as outlined in this table, at Romer Labs in Union, Missouri. Samples were screened via the LC-MS-MS technique, and the survey results represent samples sent in for surveillance testing only and does not include any sample that was submitted following clinical signs on farm. So far in our data set, we have 214 samples coming from 13 different states, as highlighted on this map. And the majority of the samples so far have been submitted from the Midwest, which would be highlighted by states shaded green. When we look at our survey over time, this chart represents the occurrence of mycotoxins. Up the primary y-axis, we have the number of samples that have been analyzed, which also corresponds to the height of the gray bars and the red shaded numerals. So again, this year in our 2024 survey, we have 214 corn samples that have been submitted. Across the x-axis on the graph are the years of the survey, and up the secondary y-axis, we have the percent of samples that were positive for the different mycotoxins, which are represented by the different colored lines on the graph. In the interest of time, I'm going to skip over some of the data, but the full report is available on our website where you also found this video. Highlights for the 2024 crop would be zearalenone, following this purple shaded line through the center of the graph. This year, this is our highest occurring mycotoxin in the data set, with 71% of samples testing positive for some level of zearalenone. Next, following the dark green shaded line, we have the type B trichothecenes. At 69% of the samples have been positive for some level of those toxins, which is up slightly from 64% last year. And then following the dark blue shaded line, we have fumonazins, which you can see a decrease from last year. This year representing 58% of the data set is positive, down from 82% in the previous year. On this graph, we have the mean of the positive samples represented. So those samples that were positive, what was the average concentration in parts per billion up the y-axis, and then years again across the x-axis, and the different toxins represented by the different colored lines. We look at the toxins on concentration level. We see that fumonazins are the highest that we find on average this year, averaging over 3,100 parts per billion of fumonazins in our samples that were positive, up from close to 2,300 ppb last year. This year, looking at type B trichothecenes, we are averaging 518 parts per billion, which is down from 1,425 parts per billion last year, and is one of the lower concentration years that you can see over the course of our survey data set. Next, we have the type A trichothecenes at 55 parts per billion on average, up slightly from last year. And then again to note, our zearalenone levels averaging 42 parts per billion, which is down from the past several years in our survey. Additionally, since aflatoxins are of high importance and concern to many people, I want to point out that our aflatoxin levels are down this year, averaging 4 parts per billion. As you can see, that's trended down the last several years in our survey data set. A quick overview, looking at our maps. Each map that I'm going to show represents a different mycotoxin, which is listed at the top of the slide. And then when we look at the different colors on the map, our light gray shaded states, we do not have any samples submitted from. Our dark gray shaded states, we have samples, but so far they've been below the limit of detection for the toxin that's represented. And then in this graph, we have yellow shaded states, which represent states that on average were below the 20 part per billion threshold. So each different toxin will have a different threshold, which you can find in the lower left-hand corner of the slides for the respective toxins. Again, here we have 20 parts per billion is the threshold. If we had any states that were above that on average, they would be colored red. Looking at our map, this year Missouri is at the top with 36 samples have been submitted out of Missouri. Only 3% of those samples, or one sample, were positive, but it was at 19 parts per billion, so very close to that 20 ppb threshold to be shaded red. Next, we have Kentucky is our next highest level on average at 9 parts per billion. But you can see for the most part, we haven't found a lot of aflatoxins in our data set this year. Most likely due to the fact that we don't have a lot of southern states represented. And those states that have had some positive samples on average are lower than what we've seen the last several years. Next, this map represents the type B trichothecenes, which would be the family that includes deoxynivalenol or vomitoxin and related metabolites. Here, the color scheme is the same, but the threshold to go from yellow to red is 1,000 parts per billion. So you can see we have 2 states that are shaded red, Illinois and Indiana. And when we look at our table, we can see the individual state information is listed out. Illinois is at the top. We've had 9 samples submitted from Illinois. 89% of those have been positive for some level of type B trichothecene, and the average for the state is just over 1,600 parts per billion. This map is for fumonazins. The threshold here to go from yellow to red is 2,000 parts per billion, and you can see a cluster of red shaded states here towards the center of the map. Again, when we look at our table, we can see that Tennessee has our highest average contamination in our data set. There have been 4 samples submitted out of Tennessee. All of them have been positive for some level of fumonazin, and our average for the state is approaching 6,900 parts per billion. Next, just to note, Missouri, since there were a fairly high number of samples submitted out of Missouri at 36, all of those have been positive for fumonazins, and the average there is approaching 6,400 parts per billion. Next, we have zearalenone. Again, the threshold here to go from yellow to red is 100 parts per billion, and our only red shaded state is Nebraska, which is just above that threshold at 106 ppb. But you can see there have been 32 samples submitted from Nebraska, and all of them have been positive for some level of zearalenone. Finally, looking at our type A trichothecenes, this is the family that includes T2 toxin that you might be familiar with. Again, the threshold to go from yellow to red is 100 parts per billion. We have no red shaded states this year, but Minnesota is at the top of our table, averaging 91 parts per billion, so approaching that 100 ppb threshold. In this graph, we look at the co-occurrence patterns over the course of the survey. Up the y-axis, we have the percent of samples positive for the different categories, and then the years across the x-axis. The green line represents those samples that were below the limit of detection for every metabolite they were screened for. The yellow line represents samples that were positive for just one family of mycotoxins, and then the orange line represents the samples that were positive for more than one family of mycotoxins. This year, when it comes to co-occurrence, we're seeing 74% of samples have more than one type of mycotoxin detected, down slightly from 78% last year, but you can see over the last 5 years of the survey that has been increasing in our trend of finding more than one type of mycotoxin family present in our data set. To look at this data in more detail, this is our co-occurrence profile. So taking that same graph as before, but now looking at the specific toxins that were identified. We have 10% of samples that were below the limit of detection for all of the toxins they were screened for this year. When we look at samples positive for one type of mycotoxin, we have 16% of the data set, and most frequently, fumonazins were found on their own in 7% of samples. Next, in the orange shaded bars, we have the samples that were positive for 2 families of mycotoxins, which it represents about a third of our data set. And the most common co-occurrence pattern here would be the combination of type B trichothecenes plus zearalenone in 18% of samples. And then finally, on the far right-hand side of the graph, we have samples that were positive for more than 2 types of mycotoxins, which represents 45% of the data set. And when we look at the most frequently occurring combination here, we have the trifecta of type B trichothecenes plus fumonazins plus zearalenone occurring in 31% of our samples. In summary, again, we have 214 corn samples representing the 2024 U.S. corn crop. 90% of those have been positive for some level of mycotoxin, and 74% of those have been positive for more than 1 type of mycotoxin. Again, the most frequently occurring toxins are zearalenone in 71% of our data set, which is very similar to what we saw last year. Next, we have type B trichothecenes in 69% of samples, up slightly from what we saw last year. And then fumonazins rounds out the group with 58% of the samples positive, down from 82% last year. So that's really our biggest change in the data set. We do encourage continued sampling and monitoring over the course of the year to understand what contamination looks like in your operation or on your farm. If you'd like to receive the results of our monthly mycotoxin updates to your inbox, you can sign up for our e-newsletter, The Digest, and you can also find the reports online at our website, www.dsm-firmenich.com/mycotoxins-survey. And if you have any questions, feel free to reach out to myself or my colleagues on the team or your DSM-Firmenich representative. Thank you.